Morning Year 5s, it is Friday once again. We've got ourselves through another week, so well done with that. Maths first, let's have a look at our do now. So here are the do nows. And then there is, oh my camera's too far forward today. There we go. There we go. Right, so this should all be done pretty sharpish from us all now. So round to the nearest 10, we've got the number 57. That's obviously closest to 60, so 21,260. Nearest 100, let's have a look. Ooh, close, 257. So 50 is the halfway mark, so that's closer to 300. So 21,300. And then nearest 1,000, 1,257, or 1,200 is still closer to 1,000 than 2,000. So 21,100. No, sorry, yes. Nearest 1,000. 21,000. There we go. Did I say 21,100? Oh dear. Nearest 1,000. 21,000. 46 divided by 20. Well, we can divide by 10 to make 4.6. And then just as with multiplication you double it, with division you halve it because it's involving 2. So when it's times by 20, you times by 10 and then times by 2, double it. So with this one, we'll halve it because divide by 2 is half. So, half, well, this one's nice and easy, isn't it? Half of 4 is 2, half of 6 is 3. So my estimate is going to be 2.3. As an estimate, that might not be right, okay? But it's near. This one here, we can change 13 to 10 and then just 9, put a 0 on the end there, it becomes 67,090. Might want to round that to 67,100 maybe. 7.8 centimetres into millimetres. Don't forget there are 10 millimetres in a centimetre, so we've got to do something with 10. It's either going to be 78 or 0.78. Okay, so you've got to use a little bit of logic there. Well, if 10 millimetres is 1, going to be more likely to be 78, isn't it? Now on the sheet I forgot to put the metres in there. Okay, well that one is metres, so apologies for that. So 1,340 metres. Well, there are 1,000 metres in a kilometre. So this is going to be, and there's 1,000 there. So that means there is 1 kilometre. So 1, and then just put the rest of the numbers. There you go. And I'm going pretty fast with this, but it's I do now. It's meant to be pretty sharpish, and if you don't get it, you know, pick it up as we go each day. 1.55 is a percentage where you've got one whole thing, so we know one whole thing is 100, and then 55. 9% we should know is 0.09, not 0.9. 0.9 is 90, remember. And then 75 hundredths, you should know that is equivalent to 3/4. There's no count. You shouldn't be looking at that going, oh, I've got to do something. You should know 75 hundredths is the same as 0.75. Number fact, that is 3/4. Okay, if you didn't get anything else on the sheet, that one is the most important to you and your maths. 2D and 3D shapes. How many vertices does a square-based pyramid have? Remember, vertices is the vocabulary for corners on 3D shapes. We say vertex, one vertex, lots of vertices. So a square-based pyramid where you're going to have 1, 2, 3, 4, and then you're going to have 1 on the top. So there's going to be 5 vertices. How many faces are on a sphere? Or a ball? Well, there's one. There's one whole face. And I draw a shape with 2 pairs of parallel lines. Well, I might just draw myself a rectangle then. There you go. Those 2 are never going to meet. And these 2 are never going to meet. Because if I carry on drawing them, they're never going to go. And then this one with this one, they're never going to meet. Lovely. Right, on to the tasty business of today. So, I'm just going to put it over there. All week, you've been doing some work on coordinates. And from what I can hear, from what I've seen, what I've been sent, or just from what people have said on the phone this week, or emails, you've been doing really good with this. So, because it's been a relatively new skill, especially the 4 quadrants. So today we are going to look at what you can do with those 4 quadrants. So we've been plotting coordinates, we've been understanding x and y, and this is where a lot of year 5s, when you see this at first, you're like, oh wow, this is what year 6 is going to be like, and year 7, oh, it's really hard. And then, because it looks weird, it looks very technical, but actually it's very, very simple, which is the case of a lot of maths. Maths just start, for year 5, it just starts to look complicated, but the skill is still there. You know, it's quite simple still. So, we're going to be doing some translation. Now, you might know translation as language, changing English to German, translating German back to English. Translation means to change, but your meaning stays relatively similar, doesn't it? Okay, so if you translate the word dog from English to German, the German word still means dog. Okay, and that's the same with shapes. When you translate a shape, you are changing it from one place to another, but it's staying the same. Okay, so instead of saying, oh, I've moved this shape 4 places to the right and I've moved this shape 3 places down, you can just use the coordinates. So, for example, if there was a translation that was described 3, 5, that doesn't mean it's at it's at the coordinate 3, 5. It means that the whole shape has moved 3, 5. And what that means is, it means it's moved along the x 3 places, and because it's positive, you know that goes that way. And it means it's moved 5 places on the y, and because that's positive, you know it's gone up. Think about this week. If I said to you 3, 5, you'd go to the right, and the 5 would be up. If they were negative, you'd go to the left, and you'd go down. So essentially, these mean different directions. So if, let me get my pad back actually. So if I could go down here a bit, if you have a translation coordinate and your x is positive, that means you're going to go to the right. If your y is positive, that means you're going to go up, as you would normally do. But then there's lots of different combinations, isn't there? You could have your x, which is negative. Well, that's going to make you go to the left, because that's the way you go, isn't it? On your x-axis, -1, -2, -3 is on the left. On your y, you could still have positive, so you would still go up. Okay. So your y could still be positive, and that would still make you go up. That would mean you'd have to go to the left and then up. You could, though, have positive, which makes you go to the right, but your y might be negative, which means you go down. In my brain, negative means the wrong way, or the opposite way. Alright, so if at the very least you know how to use the first quadrant, you can do this, because if you see a minus, you know to go the wrong way. Okay, so let me talk you through what it looks like. If you're sat there going, what? That's fine. So, this first shape here, I bet I can zoom in a bit more with this, can't I? Yeah, let's have a look. Let's go a bit more into that. We'll leave it there. Cool. Okay, so this first shape here, it's been translated from the number 1 is the original shape. So number 2 is the original shape. Because on here I've put tune into the home learning video to find out what to do, because it would have been too much to type. So the number is the original shape. That's where what is that, right angle triangle? That's where it lives. But it's been translated down to here. Okay, now you could say, well, that's moved, well, you can visually see that's moved to the left and then down a bit. But we can be more accurate. Instead of saying, oh, this point has moved this far, this point has moved this far, they've all moved the same, because the shape hasn't changed. Look, it's still 2 squares across, it's still 2 coordinates across, and it's still the same up. So it's been translated, it's not been altered. Okay, it's not become a different shape. Okay, so you can just say that all of them have been moved in the same way. So you can pick any point. You don't have, there's no like proper place to start. What I would say though, is if you pick somewhere like this one, you might lose where your point is. I would pick this one here because there's nothing in the way of you counting. So, I'm going to go always X first, so I'm always going to go across. So it's 1, 2, 3, 4, 5. Okay, so, put my paper away again. This first one has been translated. I'm writing it, but I'll show you it at the end. What did I just say? 5. 1, 2, 3, 4, 5. Okay. Now it's gone to the left. That feels like the wrong way. So that is going to be -5. And then it has gone 1, 2 down, which again is the wrong way. So that's going to be -2. So the first answer, the first translation, the shape has been translated -5, -2. Because it has gone five points, 5 places to the left, and it's gone 2 down. Okay, and all of those points have done that. If you don't believe me, you can check. 1, 2, 3, 4, 5, 1, 2, and then this one here. 1, 2, 3, 4, 5, 1, 2. All of them have gone 5, 2. All right. Let's have a look at the next one. And honestly, that's it. Well, I'll zoom out a bit for that one. That's it, okay? As long as you remember that if it feels like the right way, it's a positive number, and if it's going the wrong way, it's negative. And remember, you do X first. So, next one here, let's have a look. Now we've got 4 points here. 2 is the original shape. It's quite far away, remember? I'm always going to go X, and my hand naturally goes like that. It's like when you read. You don't read, you go left to right when you read, don't you? So go along the X. So, I'm going to pick this point because nothing's going to get in the way. If I do this one, I'm kind of going to lose. Now, there is a problem here because that corner should be there. It was really hard for me to make this sheet. So, that should be on there. I'm not going to use that point. I'm going to use this one here. So, 1, 2, 3, 4, 5, 6. And that's in line. So, the second one has moved 6. And it's +6. It's not negative. It's not -6. It's 6 because it's gone the correct way along the X, hasn't it? Okay, it's going towards the positives. And then 1, 2, 3, 4, 5. Making sure that that is the same corner on that shape. Now that's 5, but that's gone down the Y, so that's still minus. So your next answer should be 6 -5, because it's gone 6 to the right, but it's gone down 5. It's easier if we just put the camera up there. Cool. Let's have a look at the next one. I'm going to go through these ones with you. Hopefully you're picking it up. And there you go. So shape 1 has been translated, and you just write it as a coordinate. Now the shapes get tastier and more different. More different? Does that make sense? But the concept's the same. Okay. So this one here, the shapes started at 3. It's actually not moved much along the X-axis, has it? So, I'm going to do this one here. It's only moved 1. It's only moved 1 across. So the next one is going to be 1, because it's positive. So it's moved 1 there, and then 1, 2, 3, 4, 5, 6. And that went up the Y in the positive way, doesn't it? It went towards the positive numbers, so there's no negatives there. So number 3 is 1, 6. Number 4, I might use the cut. I might use this end again. So the original one is here, right? Actually, I'm not, because if I use that point, I'm going to go into the shape, and I can't see. You can predict, but for today, I'm going to go on this end just so I can follow the lines. So the original shape is 4. So X first. I'm looking at this top corner here. So it's gone 1, 2. So it's gone the wrong way. It's gone to the minuses. So it's going to be, the X is going to be -2. There, and then I need to get to this top one here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is, now is that -10 or 10? It's 10, because it's gone up. It's gone up you've still gone up the Y, which is the positive way. Okay, cool. So, just to check, 3 and 4 were 1, 3. Sorry, I shouldn't have put brackets for my numbers. I should put dots there. So the third one is 1, 6. And the fourth one is minus 2, 10. You could look at that and know, oh, that shape's gone to the left a little bit. And it's gone up quite a lot. Okay? Was it just 4 I gave you? Yes. Yes, it was. And a little bit of a tasty challenge at the end. So, quick look at this challenge. Ooh. Dave has conjectured, so discussed, that the translation of his shape is 4 minus 8. Prove whether he's right or wrong through logical discussion. So you just need to write down whether he's right or wrong and why. You'll see things like this. You'll see a shape, and then you'll see a shape again, but with 1, 1, 1. That means that's the translated shape. So it's the next one. Okay, it'd probably make more sense if it was A2, B2, C2. So he started on that shape, and this is the translated shape. He thinks that it has been translated 4 minus 8. Now you could look at that and think, potentially 4, but it can't have gone minus 8 down. It's correct, it's the right direction, 4 minus 8, but is it? Now his point, let's go with this one here. It's kind of in between two intersections. So 4, 1, 2, 3, 4. Well, he's wrong, isn't he? Right at the start, he's wrong. It's not been translated 4. It's been translated 4, 5, 6 minus 2. Okay, so he's wrong because it's been translated a lot further on the X and not as far down. So I wonder if he just read it the wrong way around. 1, 2, 3, 4, 5, 6, 7. No, he didn't even read it the wrong way around. Dave was just not understanding translation. So, there you go. I hope that made sense. I've tried to be able to do that as much as I can for my own home. And that's just an insight into something we would have been doing in Year 5 right now. Something that looks really complicated, something that's really fancy. And actually, as long as you understand X and Y and where to go when it's negative or minus, then you're sorted. Have a go. See how you get on with that. Or you've been doing the video alongside it. So, brilliant, fantastic, and great work this week because that was something rather new to all of us.